Happy Wednesday, everyone! Thanks for joining us for another Planetarium live stream. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station. So happy for you to be joining us this afternoon. Our plan for this afternoon is going to be a little different than what we originally had planned, and that is mostly because today, this afternoon, was intended to be the scheduled launch of the SpaceX and NASA Demo 2 mission, where they were going to be launching astronauts into space aboard the Dragon capsule. But unfortunately, that launch was scrubbed due to weather, and you might have been joining us. We actually had a watch party on the Planetarium Facebook page. By the way, if you have not liked and subscribed to the Planetarium, be sure to head to the Arvin Gottlieb Planetarium page and shoot us a like there and subscribe. But we were watching together, and if you missed that, the launch was scrubbed today. The reason, specific reason, the main specific reason being that let me make sure I get my wording right. So it was specifically the strength of the electrical fields in the upper atmosphere that were cause for concern. They didn't see any lightning strikes, so to speak, but the launch actually could have caused lightning, and that generally would like to be avoided when you're heading into space. So unfortunately, the mission was scrubbed. Everything else about it went according to plan. Everything went perfectly, and it was a great wet test, as they call them, with everybody sort of paired and the whole rocket fueled up. They actually filled the rocket with fuel, and it wasn't aborted until about 15 minutes before launch. So sad that it was aborted last minute, but good news that everything was safe and everything went according to plan. And these things are planned for, again, for the crew's safety. Now, don't worry, because NASA has already planned for this. Just in case, they always reserve a second launch date. And that launch date is not too far away. It's this Saturday. The launch window will be at a slightly different time. It'll be at about 2:20 p.m., so a little bit earlier in the day. But that is the current backup plan. So, of course, they'll be tracking the weather as we get closer to that. And if that window doesn't happen, they'll extend again. So we will be launching American astronauts into space aboard American soil sometime soon. Just a little kind of fun facts and information about just launch in general, and more reasons why it was aborted. You might have been wondering, well, why couldn't they just waited 10 or 20 minutes for the weather to pass? The weather actually looked pretty good about 10 minutes after the intended launch time. The reason is because this particular launch window was what's called an instantaneous launch window. So their window, so the available time where they were scheduled to launch, was right at exactly that time. So right at 3:30 or whatever time the launch was scheduled to happen. If they missed that, even by just a minute, the whole launch window will be thrown off. And this is mostly because these astronauts were trying to get to the International Space Station, which is something that's in low Earth orbit. So it's orbiting pretty close to the Earth, about 250 miles above the surface, which is relatively close in terms of space distances. But because it's so close to us and because it's moving so quickly, basically the amount of fuel that they were planning on taking up was only enough to let them get to the International Space Station if they had launched right at that moment. If they waited 10 minutes, then they might not have been able to catch up with the International Space Station. It could have passed a little bit too far, and they wouldn't have had enough fuel to actually reach it. So that's what an instantaneous launch window is, as opposed to what they call a continuous launch window, which is just more of a range. And that's fine for rockets that you're sending into higher Earth orbits or other planets, for example, because it's a little less important to be that exact for those rockets on those scale. So just a little information about that. And so the reason they picked the window or the backup day for Saturday at that specific time, again, all has to do with the synchronization of the International Space Station and the crew up there with the crew that is being launched. So the International Space Station operates based on a different time zone to be more international, obviously. But when you're sending astronauts to space, you want to make sure they're well rested, and so basically these launches are planned to be at just the right time, so that when the astronauts get to space and they have a little bit of time while they're waiting to catch up with the International Space Station, they can sleep and they can catch up with the sleep schedules of the astronauts on board. The astronauts on board can safely help the astronauts in the capsule connect to the International Space Station and safely board. So a little information about that, why that timing is important there. We did have a couple questions, and I wanted to address. Let's start with a question actually that just popped up from Eric, asking if this mission was going to be bringing anyone or anything back from the International Space Station. That's a good question, and the answer is no, mostly. They may be planning to bring some experiments back, but this was a demo mission. So that's why there were only 2 astronauts aboard, while the Crew Dragon capsule can actually carry up to 7 astronauts. So right now it's configured to only carry 2, and all the other seats were taken out. They're actually removable, and they were able to use those spaces in the capsule for more cargo. So they were planning to take a bunch of experiments up there, so Doug and Bob, the 2 astronauts going up there, are planning on staying docked up at the International Space Station for potentially about 120 days, and that could change. And they will actually be doing some science up there, but the point of this mission is not necessarily to do science. It is just to test the capsule with humans. And then there is another launch, which is called the Crew 1 launch. That's going to be launching 4 astronauts who've already been selected, and that is targeting late 2020. So that will be the first official scientific launch with crew heading up, not necessarily to test the capsule, but to actually do regular science aboard the International Space Station. It'll be a regular flight, essentially, and that's the hope. Yep, so that hopefully answers your question. Again, I don't know if they'll probably be bringing some experiments back, just they often plan on doing that. One other question that Tammy actually asked when we reposted one of our previous live streams on Monday, and I wanted to thank you all for being flexible with our changing our live stream schedule a little bit. We just had something come up and weren't able to live stream this Monday. So I hope you enjoyed the rerun of the Solar System Tour if you missed that. And Tammy did ask a question on that post on Monday. Well, first of all, Tammy says, thank you so much. We've been enjoying these and intend to keep watching for as long as you keep doing these. Thank you so much, Tammy. I'm glad you're enjoying them. I'm having fun doing them too. And I intend to keep doing these until I get told to stop, basically. So Tammy does have a question. Is Pluto too far away from Earth for anyone to land on it and explore? And that is a really awesome question, Tammy. It's not too far away, fortunately, for us to visit during our virtual live stream right now. So we are back in Space Engine, my simulation of the universe, and we can go to Pluto just by typing in Pluto in the search bar, basically. But it is not that easy to reach Pluto. In fact, for all the decades of space exploration we've been doing, both crewed and uncrewed, we didn't visit Pluto until 2015, and this was the New Horizons probe. Now, the New Horizons probe flew by Pluto in 2015 and took high-resolution photos, which we can see here in Space Engine. But you might be surprised to find out that although it passed Pluto in 2015, it actually launched in 2006. So it took nearly 10 years for this spacecraft to reach Pluto. Now, this spacecraft wasn't just moseying over there. New Horizons was actually the fastest man-made object ever launched from Earth, traveling at an escape velocity speed of 10.1 miles per second. So it was the fastest thing we've ever sent, and even that took almost 10 years to get to Pluto. To answer your question, it's not necessarily too far away for us to explore, but you just better bring a lot of books and download a lot of things on your Netflix account to be prepared for that. By the time you do reach Pluto, though, I wanted to just share this kind of cool graphic that I brought up before, but if you haven't seen it. It would actually also, it could take longer to reach the surface of Pluto because a lot of people don't realize that Pluto actually has an atmosphere. Now, Pluto's atmosphere is very thin, but its atmosphere actually extends farther out in a wider diameter than Earth's atmosphere. So even though Pluto is a very small dwarf planet, it actually has a fairly wide atmosphere. So interesting stuff there with Pluto, and thank you so much for that awesome question, Tammy, and thank you so much for continuing to tune in. Like I said, I'll plan on keep doing these as long as I can. We do have a plan. We're thinking about plans, actually, to continue these live streams in some capacity, even after Union Station and the Planetarium open. By the way, I just wanted to briefly touch on that. Union Station has announced plans to reopen the Planetarium and the Science Center. I won't go into too many details there, but we can post a link to the announcement about those plans. We are opening very slowly and carefully, of course, with considerations to the ongoing situation that the world is in right now. Just be sure to read up on our plan for that so you know when you'll be able to come back. We are starting with limited capacity in the planetarium, and we're also starting with just Union Station members, but we are quickly opening up to the general public. Just remember that you can purchase tickets online. In fact, for the time being, we are only offering online and pre-purchase tickets for those shows. But there'll be more announcements about schedules and things, but don't worry, we will be back soon, even at a limited capacity, but I'll see you under the stars at the planetarium, and we'll be doing some more real star tours there, although these are real star tours too. They're just a little bit different. Okay, so for today, I guess I didn't mention this. I should have mentioned this off the bat. So we were originally planning on talking about the Demo 2 mission, the SpaceX and NASA mission. We were going to show some highlights about that, and well, I don't have anything to show because it was scrubbed. We will be live streaming on Saturday, so you can join us for a watch party of the live stream. Hopefully that launch goes forward then, and we may look at doing a stream and talking about some highlights there after that. But for the time being today, I figured I would just give you guys a star tour that we missed on Monday. So we missed our weekly What's Up tour. So I figured today we would just take this opportunity to kind of, chill out and just have a regular star tour since it's been over a week for you all. So let's find out what's up in our night sky for the next week or so. We are going to return over to our favorite free planetarium software, Stellarium. This is a great piece of software. If you haven't downloaded this yet, it's available for Mac and PC. And if you are just on a smart device like an Android or an iPhone, there are a lot of programs similar to this that you can explore the night sky that way. But for our virtual stream, and since we are coming to you live from my desktop computer, we are going to be using Stellarium. And this is giving us a live view of the sky. My apartment is not on the steps of the Liberty Memorial, but this is the spot I've chosen, at least, for our backdrop, just to make us feel like we're at home in Kansas City. But bear in mind that the stars I'll be showing you tonight will be stars that you can see in a lot of places on Earth. The exact positions of the stars are the same stars that you would see anywhere on Earth at our same latitude. So let's actually talk about that for a moment. I've got my virtual, well, not virtual, I guess this is the opposite of virtual. This is my my sort of physical planetarium. Let's actually go back over here. This is called an armillary sphere, which is kind of like a three-dimensional planisphere, which is a star map. This is just a really great tool that I like using to help us understand how the stars are related to the position of the Earth. So here in Kansas City, we are at about 40 degrees north. And if you're watching from somewhere besides Kansas City, thanks for tuning in. And you might be at a different latitude, but here in Kansas City, and the stream, or the star tour we'll be seeing during our stream today, it will be at 40 degrees north. So the Earth is inside our celestial sphere here. This is how the stars are laid out. Of course, the stars are not the same distance to each other. They are variable distances, but this is, again, just a helpful tool to kind of understand what the night sky is like relative to the Earth's position. So if we look in here, first of all, we know that the Earth is tilted on its axis about 23 degrees, and we can see that tilt thanks to this little knob up here. So that's kind of how the Earth is tilted. And this little guy around here that appears invisible because of my green screen is the sun. It's not relative size, but this is just showing us, again, relative positions at least. Now, as the Earth rotates, I believe I can rotate it here. As the Earth rotates, if you were at the same latitude as someone else, so if you were in Asia, for example, at 40 degrees north, you would have the same stars as we do. And that's all because the Earth is rotating around a single point, which is the North Star. The North Pole extends an imaginary line straight up into the sky, pointing at the North Star. And so as the Earth spins around that point, if you are the same distance north, then all the stars will be in relatively the same position. So it's kind of hard for me to demonstrate here with my screen, but if you imagine you're there in North America, and let's say you're looking straight up into the sky. If I try to position this at a certain time of night, if you're looking straight up into the sky, then maybe you'll be looking at, say, this star right here. Well, at a different time of night, at a different part of the Earth, if you're at the same latitude, so if you're at the same distance north from the equator, you can see how you would see the same stars, and they would be in the same position relative to an observer in North America. Now, we're going to see more of how this affects our view of the night sky during our star tour, but I just want to point that out that if you've been tuning in any of our live streams and you're not from this area, then chances are you'll be able to see a similar view of the sky. And even then, if you're farther north or farther south, you'll still be able to see a view of the sky. It'll just be a little different, and I'll explain how in a minute. But for now, we want to get to our night sky, of course, and in the daytime, the sun is so bright that it drowns out much of the surrounding starlight. So we are going to go ahead and fast forward time here, and we're going to see if we can get that sun to set. I always do this too quickly. We're just going to let it slowly set here. Setting over our lovely Kansas City horizon. Now, I wanted to point out something really quick. As the sun is setting, you may be able to see a couple bright points of light near the sun. It'll be pretty difficult to see, though, and I'm not even sure really if you'll be able to see them in the sky, in the actual sky right now. It's just our simulation makes them fairly bright. But I wanted to point them out because you'll notice that they are not twinkling. Whereas the stars, even in our simulation here, twinkle, just like they do in the real night sky. Now, stars twinkle because they're very far away from Earth, and it takes a long time for a distant star's light to reach our planet. And by the time that star's light does reach the Earth, only a tiny amount of it is able to pass through the Earth's dense atmosphere, and our atmosphere causes that little speck of light to become distorted, making it appear to wobble and twinkle. But these two objects are much closer than distant stars, so a lot more of their light is reflected back towards Earth, and they appear as wider disks of light, so they do not twinkle. These are planets. Now, the two planets that you may catch tonight are Venus and Mercury during the sunset. However, Venus is so close to the sun, I'm not really sure you'll be able to see it. And Mercury is very faint and difficult to spot, so there's a good chance you won't see it also. But I did want to point that out because they do stand out as different from these other stars. Don't worry, though, these aren't the only planets you might see tonight, and we'll mention those later in our tour, the other ones. But Venus was a very prominent point of light earlier in the spring and in the winter in our early evening sky. But if you're wondering where it went, that is where Venus is just continuing on its orbital path around the sun, and right now it's a little bit too close to the sun in its path relative to the Earth for us to be able to see it very clearly at night. Now, once the sun sets, and usually we wait about an hour after sunset before we do some stargazing, because even right after sunset, there's still a lot of twilight and a lot of light pollution. But about an hour after sunset, which is pretty late right now, about 10 p.m., you'll be able to see all the stars. And it looks like Mercury will still be above the horizon, so as long as there's not a building in the way, and as long as the sky conditions are good, and you're far away from the light pollution, you may be able to catch Mercury. It is pretty tricky, though, but it is one of the other planets that is occasionally visible to the naked eye. Let's talk a little bit about light pollution, because you can see here in my simulation of Kansas City, I was able to flip a light switch that turned every light off in downtown. Of course, this is not how real life is. In downtown Kansas City and near many cities and other towns and areas of civilization, there are often a lot of man-made light sources like buildings and streetlights and car headlights. These lights shine up into the sky and bounce off our atmosphere, and they make the sky kind of glow when you're near the city, and that's why it's really hard to see the stars. So if you want to go stargazing, if you want to see a view of the night sky like this, again, this is not what you'll see in Kansas City, you'll have to travel about an hour away from town. If you drive about an hour away from Kansas City, to the west, I usually recommend, you'll see a much better view of the night sky. Now, I wanted to show you guys something kind of cool. I'm going to do a quick search in whichever search engine is your favorite, and I'm just going to search dark sky map. And the first or second result will probably be a great website, and there are many different websites and sources for this, but if you search for a dark sky map, and you can find similar things on your smartphone devices, you can actually find a map of light pollution. So if I zoom in here on Kansas City, you can see a map here with a map of light pollution superimposed on top of it. And this is a really helpful tool for figuring out where to go stargazing. So obviously, in downtown Kansas City, there is a lot of light pollution. And driving out of town, you can get away from light pollution, but you'll notice even a place as far away as Lawrence or even Manhattan still has a lot of man-made light pollution. Now, we're lucky here in Kansas City because to the west, there are a decent number of places that have a decent amount of, or a decent lack of light pollution. And as you can see, of course, farther in the west, you have sort of pure night sky spots. But anywhere east of here, you can see there are not a lot of great places for stargazing. So we're lucky in Kansas City to be pretty close to some decent stargazing spots. down to the southwest is where I usually head if I want to find a good spot for stargazing. So again, I just Google searched, or well, you can use whatever search engine you want, but I just searched for dark sky map, and I found that map, and that's a great tool to use to find a better spot for stargazing. Well, let's pretend we drove out of town to find a good spot, and we are looking at our night sky like this with about 2,000 stars visible to the naked eye. Let's start in the north. Now, I like starting in the north because there are a pair of famous patterns here that a lot of us recognize. These are our dippers, the Big Dipper, and the Little Dipper. Now, these are not actually official constellations. These are what are known as asterisms, which are unofficial star patterns. The reason we have this designation is because there is a limited number of constellations. In fact, there are only 88 constellations. And I can put the constellation lines up for you. Maybe. Come on. Oh, hang on. There we go. There are the constellation lines. So, like I said, there are 88 constellations. I'm pausing for a second because it looks like maybe we have lost some audio. If you can still hear me, can you just drop a mention in the comments? That may be limited. Audio is very low. Okay, let me just adjust things a little bit higher. Boost the sound a little bit. Hopefully you can hear me a little better now. All right. So again, chime in the comments if that's better. We're, even though we've been doing this for a few weeks, we still, are figuring things out as we go. Okay, so I did get a quick question, by the way. Another question from Eric asking if there's a website we can find satellites that will be traveling our night sky. And I'm pretty sure there is. Let's see. So. I'm just did a Google search for satellite finder or space satellite finder. There are a couple websites that offer real-time tracking. I don't have time to try these out, so I'm not going to endorse any specific ones. But again, that is a great question. So again, Eric was asking if there's a website you can that'll help you find satellites, and it looks like there are a few. And the big one would be the International Space Station, which orbits the Earth once every 90 minutes, and depending on the angle it is relative to you and the sun, then it can shine pretty brightly, and it's a fun thing to spot. All right, so back to our night sky tour, talking about constellations. There are 88 constellations. These were picked back in 1930 by an organization called the International Astronomical Union. That's the same group of people who recently demoted Pluto, so we thank them for that. But these aren't a lot, and many of these constellations are from Greek cultures. So a lot of the mythology stories, especially in the Northern Hemisphere, were adapted from Greek mythology. Some of the southern constellations were based on constellations developed by European explorers. So there's sort of a limitation, or there's a limited amount of diversity in the constellations, I could say. And you can probably imagine how cultures around the world probably see more than just 88 patterns up there, and they probably see a lot of different shapes. And for that reason, astronomers designate any shape that's not an official constellation. They call it an asterism. Now, to an astronomer, constellations aren't actually lines in the sky like that. Constellations are actually boundaries in the sky. Constellations are useful for astronomers for categorizing objects in space. So if they find a galaxy over here, they would say it's in this constellation, even though it's maybe not near the lines. But like I said, there are many different cultures that have different views of the sky. And I've shown this before, but I do want to point out that within Stellarium, there are a lot of other built-in constellation cultures, we call them. And if I switch to them, and I turn the constellations back on, or I try to, there we go, we can see different constellation patterns. And often when you click on these, it'll actually give you some background in Stellarium and show you different stories about these different constellations. But so here are Korean constellation patterns. So there's a lot of diversity in the night sky. And Stellarium is a great tool, like I said. But we're going to stick with the Western constellations, mostly because, like I said, that is just simply how the scientific community has agreed to categorize things in the sky. So I was talking about the dippers here. Like I said, they are asterisms. The official constellations that use these stars are called Ursa Major and Ursa Minor, which means the Big Bear and the Little Bear. And I pointed these out before, but I'm already getting kind of long-winded today, which is unusual for me. That may be joking. So we'll just point out the bears here. Now, these bears appear to have long tails, and I mentioned before in previous streams that we don't really know the reason why these star patterns appear to have long tails, and in many of the artistic depictions, these bears have long tails. Bears, by the way, in real life don't have long tails. Could have been a mistranslation from various cultures, or sort of a game of ancient telephone where different people taught different people, or different other people around the world, constellation patterns. So who really knows why these bears have long tails. Now, at the beginning, I mentioned Polaris, the North Star, and there it is. So if I fast forward time again, we can see that the stars do rotate around the North Star. As I showed before, the Earth rotates around that point. So from our relative position on Earth, this is what the night sky looks like. And now, if you were to travel to a different part of the Earth, specifically if you were to travel north or south of Kansas City, 40 degrees latitude, then this North Star would appear higher in the sky or lower in the sky, depending on where you were. Now, if you calculated the angle from the ground to the North Star, you would see that it is 40 degrees here in Kansas City. So if you traveled north, the North Star would be higher in the sky. If you traveled south, it would be lower in the sky. If you are at the equator, the North Star would be directly in line with the horizon. And if you traveled further south than the equator, you wouldn't see the North Star at all. A common question I get is there a South Star? And the answer is no. There is not a bright star that is significant enough for us to use for navigation in the Southern Hemisphere. Instead, explorers and ancient people in the Southern Hemisphere used another constellation called the Southern Cross, along with 2 pointer stars nearby to kind of triangulate where south was. But we're lucky that in the North Star, or in the Northern Hemisphere, for now we can actually use the North Star. Now, the North Star won't always be the North Star. This is due to precession, the Earth's slow wobble as it rotates around. I've demonstrated this before. If I spin a top here, we can see that it spins around very quickly. But most of the time when you spin a top, it will slowly wobble as well. And I did a really good job spinning this top, so it's not really wobbling for me. But if I kind of spin it at an angle like the Earth is rotating, we can see that it does this sort of slow wobble around like that. That's called precession, and the Earth does that as well. That wobble is pretty slow. It only wobbles sort of one full time every 25,000 years, but that's a short enough amount of time that within human history, the position of stars will change, and the North Star will not always be the North Star, nor has it always been the North Star. In fact, 2,000 years ago, the North Star was not the North Star. So Elizabeth was asking if I can explain that 40-degree angle again, and yeah, I'd be happy to, because it is a little hard to kind of wrap your mind around without seeing this in greater detail. So remember, here is the map of the Earth that I've got. I've got this globe on the inside with the layout of the stars relative to the Earth. At the North Pole, an imaginary line can shoot straight up into the sky to point at Polaris. Now, the North Star is right here, even though we can't really see it on my star map, but you should be able to see just the edge of the Little Dipper right there, with the handle going back there, and the Big Dipper below it, right there. So this is where the North Star would be on our star map here. So if you were standing in Kansas City, I'm going to rotate the Earth so that if you were standing and looking at the horizon in Kansas City, this is kind of what the Earth would be doing under your feet, right? So you can see North America there. So you can kind of imagine right there. So if you're standing in Kansas City looking at the sky, and you were measuring the angle to the North Star, that would be from this point over to here. And as you can kind of see, that is about 40 degrees. It's less than half from the equator to the North Pole. And that is what I'm talking about when I'm talking about 40 degrees. And that happens to correspond with our latitude. So the coordinates of Kansas City, latitude and longitude, roughly match coordinates in space. So we can kind of extend the lines on the Earth out into space, and we can see these lines superimposed on my celestial sphere here. Astronomers have different names for these lines. We call them right ascension and declination, but that is mostly useful for setting up telescopes and things like that. Hopefully, Elizabeth, that explains things for you. So David was asking if there are a limited number of official constellations, then who classifies them this way? And as I said, these 88 were chosen back in 1930 by the International Astronomical Union, and this is just a group of international astronomers. And again, they didn't necessarily pick those constellations for their stories or anything. They were just common constellations they were familiar with, and as mostly Western astronomers in 1930, as you can imagine, they chose many Western constellations. But again, they were only picking to designate these regions of the sky to help them organize the night sky, kind of like state boundaries. That's why they haven't changed since then. It's because these regions don't need to change. Every new thing we find can go straight into these spaces. So let's continue on. So it's already 6:30, so we are already getting kind of close to the end of our time here. We had a lot of talking about the launch, I know. So I'm going to just kind of go quickly over some new things that you might be spotting. And our skies, Gemini is going to be setting. You probably won't see it on the moon. Will be a waxing crescent tonight. Waxing means it's currently getting bigger and brighter, and crescent means that just a sliver is visible. In a few nights, we'll have the first quarter moon, where it's 1/4 of the way through its cycle, meaning it's half full. I know it's kind of confusing. And after that, the moon will be gibbous. It'll be more than full. And when the moon is gibbous, it is very bright and actually a great source of light pollution itself. So you'll also want to keep in mind the phases of the moon when you're planning on stargazing. Let's see. All right, I see Eric was asking if something will impact our weather, but I was probably to something I was talking about earlier, so I'm not sure exactly what that is. So I'm going to come back to that. Ralph was asking, asking about my celestial sphere. Again, that's called an armillary sphere, which I will spell out for you and double check that I spell it correctly. So this is ARMILLARY, armillary sphere, and you can buy these in a store or online. I got mine online. So yeah, they are called armillary spheres. And yeah, you can get one of those star globes for yourself. So we're going to continue on. We've got Leo the Lion still shining brightly up in the south, followed by Virgo the Maiden, who is kind of hiding behind the Liberty Memorial here. But we've talked about those constellations in the past, and if you want to learn how to find them, I would just encourage you to check out one of our previous streams. I wanted to focus on some interesting things that are rising in our evening sky right now. And I'm going to cheat a little bit and fast forward to a little bit later, say about close to 11 o'clock tonight, because there are 3 stars that are shining very brightly and will stand out in the eastern sky tonight. And these are the 3 stars of the summer triangle. The stars are named Deneb, Altair, and Vega. Now, Vega is the 5th brightest star in the night sky, and the Vega will actually be the North Star in about 12,000 years as the Earth's precession continues. Eventually, the North Pole will point near Vega. Vega is part of the constellation Lyra, the Harp, which is just a little harp that belonged to Orpheus, a famous poet and prophet. Lyra has one of my favorite deep space objects inside of it. It's between these 2 stars, and you can see this object through a moderately powered telescope. It's right over here. It's called the Ring Nebula. This is not the best picture of it, so I'm going to find a better one for you. Hopefully, quickly. Ooh, yeah, let's do this one. All right, so this is the Ring Nebula, and this is what we call a planetary nebula. So the Ring Nebula contains the remnants of a dead star. When stars die, a few different things can happen, and we talked about this during our previous stream where we talked about stellar evolution, but just in short, when stars die, they can sometimes explode into supernovas or collapse to form black holes, but those 2 events are actually very rare, and they only happen to very massive stars. Most smaller and average-sized stars, when they get old, they simply expand and spread their layers out into space, leaving behind these nebulas. They're called planetary nebulas. There aren't any planets involved here, but when they were initially observed by early astronomers, they reminded them of sort of planetary systems. That's why they named them planetary nebulas. The different colors, different types of gas that were part of that star. This red color on the outside is ionized hydrogen from the outer layers. The blue color is helium from the inner layers, and then there are other heavier elements like carbon and oxygen mixed in. And then that little dot in the center is a white dwarf, which is not a star, but the leftovers of the core of the dead star, a very hot but totally inert ball of gas that will continue cooling for billions or even trillions of years. And so that is the Ring Nebula, a really awesome thing to check out between these bottom two stars in the Harp of Lyra. So Eric was asking if the shift to the North Pole will impact our weather. And that's actually a really great question that I believe I briefly touched on, yes, last Wednesday. Last Wednesday's stream was really awesome. If you missed it, be sure to check it out. You can find recordings of all of our streams on the Planetarium Facebook page. But last week's stream was about fictional astronomy. So we looked at a couple different famous universes in fiction and talked about how they could possibly work with a real astronomy. And one of the universes we talked about was Westeros from the Game of Thrones universe or the A Song of Ice and Fire novels. And if you don't know, the cool thing about that planet that those stories are set on is that their seasons they vary in length and are unpredictable in how long they'll be. Sometimes winter lasts for years. And we talked about how this could potentially exist in a real planetary system. And one way that it could exist is because of the interaction of a few different things, one of them being the axial tilt, or the precession of a planet. So as the Earth wobbles, that wobble, as it interacts with things like how round the Earth's orbit is, because over time the Earth's orbit will shift from being round to being more elliptical, as well as sort of our tilt actually changes too slowly, so the angle kind of changes in addition to that wobble. So these things combined, there was actually a famous astronomer back in the day named Milankovitch, who actually plotted out these three different things. So this is the eccentricity, which is the ovalness of the Earth's orbit, that precession, that wobble, and then the obliquity, which is the tilt. And he plotted out those three things as they interacted, and he compared them to known previous ice ages that the Earth has gone through, and they actually correlated. So basically, as these three different changes in the Earth's positioning happen over the scale of tens, if not hundreds of thousands of years, they have actually been proven to impact the climate on Earth. And before anybody asks, the current climate change that we are observing right now cannot be accounted for by these Milankovitch cycles. The math does not check out. So these three things, at least, are proven to not be affecting our current changes to the climate that we've been observing. So just before anybody asks about that. But so the short answer, Eric, is that yes, this shift could potentially impact the weather, but more on a longer scale as it interacts with those other forces that change the Earth's position. All right, awesome questions, everyone. Thanks so much for asking those questions. And we're just about out of time, so I want to quickly finish up talking about these stars I mentioned. This is Vega. We've got over here Deneb, which is the tail of Cygnus the Swan. And then lastly, Altair was the eye of the eagle. Now, these three stars are starting to rise in the early evening. And in about a month, these three stars will already be up right after sunset. And that will tell you summer is here, because these three stars are part of the Summer Triangle, which is a famous asterism that helps us that has helped ancient people to determine the changing seasons. Basically, as these three stars are rising, we can see that summer is approaching, because once all three are up, that tells us summer is here. So asterisms like this were common for ancient people to track the changing seasons and the changing, so they could plan on, changing harvests and things like that. Now, real quick, the last thing I wanted to mention is that if you wait a little bit later, right behind the Summer Triangle, and actually probably under the horizon here, which I'm going to go ahead and hide, you will see a few planets rising. And actually even earlier in the evening, like around 11 o'clock, you'll see, that's not it, you'll see Jupiter and Saturn, closer to midnight rather, so this is about 1 a.m. You'll see Jupiter and Saturn rising. Now, Jupiter and Saturn are really close together right now, and over the course of the next few months, Jupiter and Saturn will be right next to each other, and we'll be up in the early evening sky. We'll for sure be checking those out during our live streams and future star tours. But these two planets are getting closer and closer together, and on December 21st, these two planets will be in conjunction. We call this the Great Conjunction, where they get as close to each other in our night sky as they ever get. They're not actually lined up in space, they're just appearing close together. But this conjunction is fairly rare. It happens about once every 20 years, just because the Jupiter and Saturn are orbiting at their own speeds. So this is going to be a pretty cool sight to see these two planets right next to one another, and we'll definitely be tracking that during our future live streams. Unfortunately, though, we are out of time for our stream for today. Again, thank you all for your patience. I'm sorry we could not talk about the SpaceX and NASA launch, but don't worry. Like I said, we will be following that launch, assuming it goes according to plan, on Saturday. So tune in and join us for the watch party. I'll be in the comment section of that watch party on Saturday afternoon, where we will be talking about the launch. We'll probably start that at around 1:45, maybe 2 o'clock. The launch is scheduled for 2:22 p.m. Central Time. So stay tuned for that. We'll see about doing a highlights reel afterwards and talking about the launch as well. I will for sure see you back here on Monday for our next What's Up stream, where we will be taking our next tour of the night sky. And next Wednesday, assuming that the launch goes according to plan on Saturday, and assuming if it doesn't, it's postponed to a different time. Next Wednesday, we will be going back to our fantastical universes of fiction, because my live stream last week, where we covered the fictional worlds, we couldn't get to everything that I wanted to talk about. So I've got a lot more notes all about fictional universes, and one of the main things you're definitely going to want to tune in for is the astronomy of Harry Potter and that magical universe. So again, next Wednesday at 6 p.m., tune in for our next deep dive live stream, where we will be covering more fantastical universes of fiction. Monday for our What's Up stream for the week, and then Saturday, this coming Saturday, May 30th, where we will be tracking the Demo 2 launch of the Crew Dragon spacecraft, the first spacecraft to launch from American soil carrying American astronauts since 2011. Thank you again so much for bearing with us and tuning in for another live stream. I hope you enjoyed the stream. It was a little different than what we were planning, but hopefully you learned something. If you have any questions and we missed them, we will definitely write them down, so feel free to add them to the comment section if you'd like, and we will revisit them on Monday. But I've been Patrick Hess. Thank you again so much for tuning in. Hope you guys have a wonderful rest of your week and weekend. I'll see you right back here on Saturday for that launch. And happy stargazing, y'all.